Hey everybody, so today we are going to look at how we find the area of a sector of a circle. So not the whole circle, but just a section of it. Okay, so that's part of our definition of a sector. It's a section or a piece of a circle that is bounded by a central angle. And if you recall, a central angle is made by two radii. So I have one radius drawn over here. If I draw a second one, kind of like this, remember that the radius of a circle is always the same, even if it looks like an egg. And it's not really a very great circle, my apologies. Okay, so it's going to be bound by these two radii. So this is our central angle right here. So all of this in here is our sector, and it's going to go out until it reaches this arc or the edge of our circle right here. So this is called our intercepted arc, which is the arc that forms that angle. Okay, so just a real quick reminder, this angle in here of our central angle is going to be the same as our angle out here on the circle. The arc and the angle are the same. So in your problems that you're going to see for this, sorry, I'm covering up the definition, the problems that you're going to see, they could give you that angle inside or outside along the edge of the circle. Either one, it's going to be the same value. Okay? All right, so my pictures did not work out very well here, but just pretend with me, okay? So, excuse me, let's talk about this first circle, which kind of looks like a circle. They get kind of more eggy as we go along, but we'll pretend they're all the same. In this first circle, let's find the area of this whole circle. Do y'all remember the formula for area of a circle? Area of a circle is pi r squared. Okay, so pi is just going to stay there because that is actually a number. And then radius is 6, and we are going to square that. Okay, so instead of picking up my calculator, I'm just going to go ahead and do 6 squared because I know what that is off the top of my head. 6 times 6 is 36, and I'm going to leave my answer as 36 pi. We always put the number in front, just like I had 5x or 12x. We don't say x12, right? So the coefficient goes in front, and then we have pi. So the area of this circle is 36 pi units squared, whatever that unit might be for this problem, whether it's inches or feet or whatever. They don't tell us, so we just say units. Okay, so this whole circle is 360 pi. So if I shaded that, that would be the whole thing, right? What if I didn't want to shade the whole thing? What if I only wanted to shade to right here? How much of the circle is shaded now? Half, right? Half of the circle is shaded. Half of the circle. So if I wanted to find the area of half of this circle, I already know the whole area is 36 pi. So I could do half of 36 pi. And what we know about the word of in mathematics is it means multiply. So I'm going to have half times 36 pi. Or what's half of 36? Half of 36 is just 18 pi. And we still have our units squared. So now I only have 18 pi shaded as opposed to the whole thing, 36 pi. Okay? Well, what if we didn't want to shade even that much? What if we stopped right here and we just shaded this little bit? How much of the circle is that? If this is half, this is what fraction? This is 1/4 of our circle. So 1/4 of means multiply, 36 pi, the whole area of the circle. 1/4 of 36, or if you took 36 and divided it into 4 equal pieces, each of those pieces would be 9. So 1/4 of 36 pi is 9 pi units squared. Okay? And what this tells us is that this essentially becomes our formula for finding the area of a sector. We need to know how much of the circle is shaded, and then we're going to multiply it by the area of the whole circle, whatever that is. Okay? Okay, so one little hint here for you is that if you didn't know that it was half, maybe it stopped right here and you're like, well, I don't know exactly how much the circle that is. Okay, we're going to talk about the arc of this shaded part. How big is this arc? How much of the circle is shaded? 180 degrees. How much of this circle is shaded? The whole thing, right? 360. So if I only shade 180 out of 360, did I say 360 or 160? I'm sorry, my brain's not working very well tonight. 180 out of 360, guess what, y'all? 180 divided by 360 reduces, simplifies to 1/2. It's the same thing. So if I change this 1/2 to 180 over 360 and I multiplied that using my calculator, I'd get the same answer. It's amazing. What degree is this? How much of the circle from here to here? Because this usually has one of these little boxes right there, right angle. So how much of the circle is this? 90. So we have 90 degrees out of the whole circle, which is 360. 360 divided by 90 is 4. This is 1/4. It's the same fraction. Okay, so this is actually going to give us our formula for area of a sector. Sorry. Area of the sector of our circle is simply a portion of the entire area. Remember, the word of means for us to multiply. So this becomes our formula. How many degrees out of 360? And then we're going to multiply that by our area formula of a circle, which is pi r squared. X is the degree of our arc. R is the radius. Now, if it's something easy and you can see, oh, that's just half, then you can just use 1/2 instead of using 180 over 360. But if you use 180 over 360, it will still get you the same answer. Okay? All right. Hopefully you paused that if you didn't have all that written down and you're ready to go on. Okay, so pause again to make sure you have the picture drawn. We're going to find the area of each of these sectors. I'll put an S right here. Find the area of the sectors for each of these. Okay. All right, so find the area of a sector. The formula for area of a sector is how many degrees out of 360 times the formula for area of our circle, which is pi r squared. So we're just going to simply substitute into our formula x degrees. How much of this circle is shaded? The shaded part is 120. So remember that 120 could be in there or it could be out here. 120 degrees out of 360. And then we're going to multiply that by pi. What is the radius of this particular circle? 6 squared. All right. I'm going to show you a little trick on your calculator. So if you will grab your calculator and follow along with me. Okay, don't just let me do this. I'll use your calculator too. You've got one on your phone. Okay, I'm going to turn mine sideways so that I can see my x squared value. Okay, I am going to type in 120 divided by 360. And then I am not going to type pi. Y'all just bear with me for a second. I'm going to skip over this, and I'm going to go right to the times 6 squared. Okay, so notice I have 120 divided by 360, and I'm multiplying that by 6 squared. See this really nice number it gives me? That is 12. Now, my answer is not 12. My answer is 12 pi, because I skipped over that pi symbol. Okay? So if I had just typed the whole thing like it showed up, I'm just going to show you this one time. 120 divided by 360 times pi radius squared. It gives me 37.699 inches squared. Okay, that does not look like 12 pi, does it? But watch what happens here. 12 pi, enter. Hello, same number. Okay, this answer is what we call the exact answer. So it is it is not rounded. Pi is there. We haven't rounded, dropped off any numbers. This is our exact answer, 12 pi inches squared. Okay. It also sometimes says leave your answer in terms of pi. And so if it says leave your answer in terms of pi, they want to see pi in your answer. So you do everything else around the pi, and then you just kind of tag it onto your answer. Okay, this thing over here, which is the same, we showed that they were congruent. This value here is what we call an approximate answer. It is a rounded to the nearest whatever. Sometimes they'll say round to the nearest tenth. Then we would have put 37.7. Sometimes they'll say round to the nearest hundred. Sometimes they'll say round to the nearest whatever. Okay, in this case, notice that the pi was put into our calculator and it is already there in that answer for us, which is why we had to round it, because pi goes on forever and ever, and we have to drop the numbers off at some point because we just don't have enough time to write them all. Okay, so for today, I believe that we will write our answers in exact numbers and exact answers, leave our answers in terms of pi just because they're a little bit nicer. Once we get into some kind of less pretty numbers, we might switch over to the approximate. Now, we always have to do approximate if we're doing a real world scenario. Like if I go into Lowe's and I say, I'm going to stain my deck and I need 37 pi gallons of paint or whatever, like they're going to look at me like I'm crazy. Okay, so in a real world scenario, it's most often that you will be dealing with approximate answers. For what we're doing right here, we're going to leave them in terms of pi. Okay, all right, with that being said, let's do a couple more. We've got these two right here. All right, so in example 2, we have a radius of 3 feet and we have a 20-degree arc on the outside, so we're looking to find the area of that shaded part. This is just a little piece of the pie this time. Notice that I write my formula down, then I'm going to plug my numbers into it. What value goes for x? X is our degrees out of the whole circle, which is always 360, and we're going to multiply that by pi. R is 3 in this case, and we're going to square that. Okay, make sure you see the difference between the little degree symbol and the multiply, or you can just leave the degree sign off if you want. Okay, so I'm going to type this into my calculator. I'm just going to go ahead and write this here in my calculator. Here's what I'm going to type: 20 divided by 360, skip the pi for now, times 3 squared. Okay, so when I do that, 20 divided by 360 times 3 squared gives me 0.5. So you can write your answer as 0.5 pi. If it makes you happy to write it as 1/2 pi, that is the same thing. Or you can write it as pi over 2. All of those are the same thing. 1/2 pi or pi divided by 2. All the same thing. Pick which one makes you happy. Okay. All right. One more of this. Okay, notice that our shaded area is a lot larger this time. Okay, it's still the same formula. How many degrees out of 360 times pi r squared? Okay, so the degrees that we have this time, is that this 150? Is that the shaded part? Please say no. That is not the shaded part. The shaded part is all the rest of this stuff going around here. Okay, so how might I find how big that arc is? The whole circle is 360. We already have 150 of it. So how much will be left for all the rest of this? 210. So all of this is 210. If you can put it there, or you can put it out here if you want to mark that arc around the outside. So for this circle, we have 210 out of our 360 times pi, what's the radius? 5 squared. So again, just for sake of, these are your notes, in your calculator, what are we going to write or what are we going to type to put this into our calculator? 210 divide 360, skip over the pi, times 5 squared. 210 divide 360 times 5 squared. That one doesn't give me a very nice number. I don't really like that. Okay, so since I see this, I mean, I guess technically I could put 14.583 pi. That's kind of ugly. I'm going to go ahead and type pi into my answer since it's pretty grody to start with already. And my answer will be 45.81 units squared. Okay, and I did to the second decimal place. If it doesn't say, always go to the second decimal place unless otherwise told. Okay, so again, if you want, okay, when we had that 14.583 pi, like, that's just ugly. I really wouldn't. If you're going to put decimals out here, like repeated decimals or decimals that, like 1/2 is different, 0.5 is different, 0.75 is different, it stops. But this keeps going, 3333333. Okay, in that case, it's probably just easier to do the approximate. But again, the majority of your questions for what we're doing right now, they're going to be multiple choice. It will tell you one way or the other. Okay, I'll be very specific. All right, last question. The area of sector AOB is 432 pi, and the measure of angle AOB is 120 degrees. Find the radius. Okay, they don't even give us a picture, but that's okay. Notice here that they give us the area of the sector. So I'm going to start with this formula. Area is x over 360 times 2, oops, not times 2, times pi r squared. Good thing I had an eraser. And then I'm just going to plug in what we know. This capital A stands for what? Area. Do we have a number for area in this problem? Area of our sector is 432 pi. So all of this right here is going to go for capital A. So I'm going to put that way over here. 432 pi. Then I have an equal sign. Then I have an x. What does that x stand for? That's our degree. How much of the circle do we have shaded? The measure of our angle is 120. This is going to be x, 120 over 360 times pi r squared. Okay, so we are going to solve now for this radius. I want to get this all by itself over here. Okay, so you can do one of two things. If you want to put this into an equation solver, if you have found one on Google, on the internet that you like to use, you could type this equation in and it will give you an answer. Okay, in order for me to do it without my equation solver, okay, here's what I'm going to do. I'm going to take this fraction and we're going to multiply by the reciprocal. Okay, by flipping that over, this 360 will divide by this 360, and 120 will divide with this 120. Okay, so I'm going to do the same thing over here, 360 over 120. So this is going to go away, and that's going to go away. And on my calculator, I will have 360 divided by 120 times 432. So that makes 1,296. Can't forget this pi that was right here. Could never forget the pi. That's delicious. Then over here we have pi r squared. Okay. So here's what's going to happen. We're going to divide both sides by pi, and they're just going to go away. So if you have pi on both sides of your equation, you can just cancel them out. They will fall off. Okay, and now I'm left with the radius squared equals 1,296. So do y'all remember how we get rid of a square on our variable? To undo squaring something, we do the opposite, which is square root. So the radius is going to be whatever the square root of 1,296 36. That's our radius. 36 units, 36 inches, 36 feet, 36 whatever. They don't really tell us. Okay? Alright, so on your assignment, it will look very similar to this. You're going to have 3 questions that are kind of straightforward. Find the sector area. Then you'll have 1 word problem where you have to work backwards with given the area. Okay? Great job. Y'all keep up the great work. Love you. Bye.